Hello, my dear friend. Welcome to this session of Wellness, Wonder, and Learning. Today, I will talk about steel making. Presently, steel is the backbone of modern civilization. From bridges, skyscrapers, and automobiles to phones in our hands, and the tools in our factories, steel gives shape to the progress. Progress cannot be imagined without steel at present. But this strength comes with a hidden weakness. Traditional steel making is one of the largest industrial source of carbon emission. Every ton of steel produced releases nearly 2 tons of carbon dioxide (CO2), making the industry responsible for almost 7 to 8% of global greenhouse gases. Now, presently, that's why it is very essential to think about alternatives are essential. What are the alternatives steel making processes? What can be? As the world races towards net zero climate goals, steel making cannot be left behind. We need steel, but we also need clean air, stable climate, and sustainable growth. This is where alternative methods like green steel step in. Green steel, yes. Hydrogen based steel making can replace coal, cutting emissions drastically. Electric arc furnaces powered by renewables can recycle old steel into new without polluting. Carbon capture and utilization ensures that every residual emissions do not escape unchecked. Green steel is not just a cleaner method, it is the future of industry, ensuring we can keep building without destroying the very planet we are building on. We will see what is green steel. In simple terms, it is steel but with a far lower carbon impact. And technically, it can emerge through several pathways such as Hydrogen-DRI, that is direct reduced iron using green hydrogen instead of coal to reduce iron ore. Electric arc furnace EAF with higher scrap uses. Recycling old steel by melting it with renewable electricity. Electrode deposition, molten oxide electrolytes, producing iron through electrolysis, still at an early stage. CCUS, carbon capture, utilization and storage, capturing and reusing or storing carbon dioxide that would otherwise be released. The purity of each route depends heavily on the source of energy, coal-based electricity versus solar and wind. Now we will see what is needed for this green steel making. That is abundant, affordable, renewable energy. Green hydrogen and EAFs only make sense if powered by clean electricity. Green hydrogen supply, electrolyzers, renewable generation, storage, and pipeline networks. All these are needed. Advanced metallurgical technology, that is efficient DRI units, optimized EAFs, and strict product quality control. Capital and financial models. High capex requires public-private investment, green bonds, credits, and subsidies. Scrap economy and recycling infrastructure. More scrap use means less demand for fresh iron ore. That is, you can reduce the mining of iron ore. Logistics and supply chains, sustainable mineral management, reliable water access, port facilities, and renewable grid connectivity. All these are required. Then accurate MRV, monitoring, reporting, and verification. Then transport systems for measuring and reporting emissions. All these are needed for this green steel. Next comes how it can be produced. That is process from pilot to commercial scale. It requires lab on pilot production, then demo, then commercial. Start by validating the technology by small scale, then scale up gradually from tens to hundreds and then thousands of tons per year. It requires energy integration, that is seamlessly combines wind or solar plants, hydrogen electrolyzers, and batteries and storage systems. Product quality verification is very essential. That is, we have to maintain strict standards for sectors like automotive, construction, and pipelines. Then economic focus is also needed. That is, green steel must command a market premium. Buyers, that is OEMs, need to support a green premium through corporate offtake agreements and policy incentives. Policy and market incentives is required. Carbon taxes, credits, mandatory green steel procurement, rules and certification, and green tax can be utilized. This will be essential. Measurement, that is parameters for measuring success. It requires CO2 intensity, that is kg CO2 per ton of the steel. Target is to reduce from today's 1.8 to 2 ton CO2 per ton down to 0.1 to 0.5 ton CO2 per ton of steel production through green pathways. Energy intensity, that is efficiency, matters, but even more critical is the cleanliness of sources, that is renewable percentage we have to increase. And capex and opex per ton needs to be competitive at commercial scale. All these are required. Then scale up speed, that is tons per year. Transition from 1000 to 1 lakh plus tons per annum should be our target. Only then we can meet the requirements. And next is policy frameworks. Sustainability auditors skilled in MRV, monitoring, reporting, verification, and life cycle assessment (LCA). Logistics and scrap management teams, very efficient, will be required to build a strong recycling ecosystem and ensure reliable supply chains. This is very much essential. Only then we can sustain. Expertise. What expertise is required? Metallurgists and material scientists. They should have deep knowledge of steel properties and performance. Renewable energy and grid integration experts, very efficient. They are required to design and synchronize large-scale clean power with industrial operations. Then chemical and process engineers, that is, they should have specialized in DRI, direct reduced iron, EAF, electric arc furnace, and electrolysis technologies. Only then they can sustain. Finance and policy specialists for project financing, green bonds, and navigating public policy frameworks. They are very essential. Sustainability auditors skilled in MRV, that is monitoring, reporting, verification, and life cycle assessments (LCA). Logistics and scrap management to build a strong recycling ecosystem and ensure reliable supply chains. Without this, there is chance of failure. Now we will talk about risks and pitfalls if ignored. Non-green energy sources results in hypocritical green steel, false or misleading claims. Raw materials and water shortages, all these add pressure on local ecosystems and communities. High production costs, because cost will not be less, it will be high. It becomes an economic burden on industries and consumers. Then scale up failures. Pilot plants succeed, but commercial plants fail, leading a loss of the investors' confidence. Weak regulations. We have to make very strong regulations. Without strong policy frameworks and certification, market trust collapses and the green premium disappears. So strong regulation is very essential to regulate all these things. What does it mean for India and how it can be made more popularized in India? Major steel consumer, that is India, is among the largest consumers of the steel worldwide, especially for construction, infrastructure and automobiles. Make in India at Manirvar vision, that is building a green steel hub, is the golden opportunity for India, leveraging affordable renewable resources, solar or wind, and young tech talent and large domestic demand. Policy push. The government can play a showstopper role through subsidies, green bonds, and strong public-private partnerships. Then comes global opportunities. Economics should be framed out. Economies like the EU and US are willing to pay a green premium. India can position itself as a leading exporter of green steel. Now we will assess why it is necessary in today's world. That is climate target. To achieve net zero goals by 2050 or 2060. Decarbonizing heavy industries like steel is unavoidable. Economic opportunity is there, that is green steel can create new industries, jobs and export opportunities. Energy sector transformation. Scaling up renewable and storage will be anchored by sustainable business model. Social stability, cleaner industries directly improve local health and community well-being. All these are the benefits. The way forward for green steel is government-private strategies. That is, we should develop green steel parks, hydrogen corridors, and tax incentives. Collaborative financing, that is, large firms and startups must co-create public-private offtake and financing models. Then transparent MRB, ensure global standard certification and monitoring, reporting, verification. Then it comes social awareness. Prepare both producers and consumers to accept the green premium. Otherwise, it cannot succeed. My friend, green steel is not just about technology. It is both our responsibility and opportunity. If today we take bold steps in investment, policy direction, and global collaboration, the sparks from startup pilot plants can ignite a worldwide green steel revolution. And remember, climate is a challenge, but it is also the very challenge that gives today's innovators and policymakers a chance to carve new directions. Will these nails in your next building truly be green? Will the nails in your next building truly be green? Green Steel asks this question, and answer is the choice we make today. Thank you.